Thank you for attending this session. I hope you had an interesting and exciting day so far here at the NAV Tech Days. So this is going to be the last session for today. It's going to be about keys and indexes in NAV, what we have. Before we start, let me briefly introduce myself. As you can see, I'm around in the Navision world also for quite some time. So I was in the keynote, I was one of the guys between the 10 and the 15 years, somewhere between. And I'm also almost as long I'm around in the internet forum, Mibuso and other forums. And I'm really, really happy to see so many familiar faces, or at least the nicknames on your cards are quite familiar to me. And I also see a lot of familiar friends. So I want to talk about indexes and keys, what this actually is, how you can use this in NAV, what impact it has actually on the performance. As you probably know, I have a 100% focus on NAV and SQL Server performance optimization. And this is actually one important chapter out of this context I want to present to you. I would like to have a very strong focus on the demonstration, keeping the PowerPoint slides down to a minimum. And what I want to show you is what you can do also today. So I will not have a look into the future, what you will be maybe able to do with NAV 7 or anything. No, I want to highlight what is possible today, what you can do right now with your installations or your customers' installations. Before we go to the hardcore content, just some basics. Which is necessary to point out. I guess most of you are also originating from the native NAV world. And we are always talking about keys, and then other guys are talking about indexes. Yeah, what the hell, what's the difference between a key and what's an index? Something like this. To keep it simple, a key is actually a kind of constraint, a kind of rule, so to speak. And the most famous key we have in NAV is the primary key. And there's a rule on this, because the rule of this primary key says that every single key value has to be unique. So this is the purpose of a key. It's a constraint kind of rule. Everything else is actually just an index. An index is a helping structure to retrieve data, no more and no less. In NAV, we're always mixing the terms up. We're always talking about keys, primary keys, secondary keys. Actually, this is wrong. Yeah, because if you remember customer table, there is a key called search name. Yeah, what is the constraint here? What's the rule about the search name? There is no rules, there's actually no keys. Actually, this term originates from the older world, from the native C-side server, where a key indeed was used for all and everything, for data retrieval, sorting, and the SIF management. But it's absolutely necessary to distinguish between those two objects actually with SQL Server, because it's different things, and they need to be handled completely different. So, just have to fill myself up. So an index is a helping structure to retrieve data. You all have an index finger, I hope so. Yeah, because you use it to point something out. This helps you to point something out. And every one of you is also working with indexes on a daily basis. And just to give you an example you're hopefully familiar with, I'm having this little book here, that's the Yellow Pages. This is from my area, from my home turf at Nuremberg area. So now assuming we want to look up something from this book. So give me anything you want to look up. Striptease clubs, okay. No problem about that. Okay, we have a reception, we don't need to go to the strip bars. Anyway, so what you don't do naturally, you won't throw this in the air, open it some page. Oh, pity that's automobile garages or stuff like this. No striptease clubs today, I'm sorry. So you have to bring your car to the garage. No, you won't proceed like this. Because the natural thing you do, because once in your life you have learned that either in the beginning of this book or at the end, there is such a helping structure. There is an index. In this case, the index is just a list of all the branches and pointing to the page where the branch starts. So what you naturally will do is, because you have kind of statistic about this, you know that there is an index that helps you to process this query. You will go to the rear end of this book where you find the index about the branches. So what you will do now is you just simply scan through this index, through this helping structure. You know that's sorted alphabetically. Every branch is in alphabetic order listed here. And sooner or later, I will find my striptease clubs. And then it tells me, okay, the striptease clubs, they all start at page 150. So from this helping structure, from this index, I will jump over to the real page, to the 150, and there I will find all my striptease clubs, including the name, also the names sorted by in alphabetic order. I will find the address, the phone number, and I don't know, maybe the prices. Yeah, I don't know. I have no idea how striptease clubs work. So this is a helping structure to retrieve the data quickly. That is the idea of this. Now imagine this. Okay. Take a deep breath. So my helping structure. Drop index, speak in SQL. Now it's gone. Pity. So what? I still want some entertainment for tonight. So what do I have to do? No helping structure. What I need to do now is I have to scan through every page. I have to read page by page by page by page by page. And someday I will reach my page 150 where all the strip clubs start. So this scanning actually caused a lot more of I/O. Yeah, I had to read more pages. So more logical I/O I have to accomplish. Still, in a decent time, I still get my result. I find my strip clubs. And that is because this little book here has a defined physical sorting. So the data within this book is actually grouped. It is grouped by the branches in alphabetic order. And within each branch, it's also ordered by a company name or whatsoever. So the data is clustered. Actually, I have a clustered index, so to speak. So now it's going to be a little more difficult. Now imagine this. Up. And another thingy here. Yeah, grateful we had good lunch. So, and that. So, hooray. That's called a heap. Yeah, indeed it is. So, no more physical sorting. It's a heap. And this is actually, I would say a smart heap, because in reality a heap looks different. A heap looks like this. So, heap means that the data is stored wherever there is some space. So now I want to look up the striptease clubs. I'm screwed. I have to perform a lot of physical I/O and logical I/O and read every bloody page of this book, hopefully finding someday my striptease clubs. So that means without a helping structure, without an index, it's going to be a difficult task. Without having a clustered index, without having data in a grouped way, I'm even more screwed. And actually for the SQL server, it's exactly the same. Or I hope that you're not storing striptease clubs in your SQL database, but actually it doesn't matter what kind of data you store, it's always the same. So this is the general idea how indexes actually work. And believe me, it's exactly the same with SQL Server. Helping structures to retrieve data. Now, having a look from a more abstract perspective, we're talking about so-called balanced trees. And this actually happens because when data is indexed, the index pages have a limited space of 8 kilobytes. So I cannot indefinitely index data on these pages. So sooner or later, I will need another page and another page and another page. This is what we have here, just a straight list without further index nodes or something. SQL Server behaves differently. It will create intermediate nodes. That's actually kind of routing points that telling the SQL Server to go either this way or the other way. So we have a lot of index nodes, intermediate nodes, and the very top level, the entry points in such an index is called the root nodes. Basically, every index is non-clustered. It's just a helping structure. And we have one clustered index actually. And the very difference is only that while all other indexes just exist of index values, for example, posting groups or whatsoever, the clustered index in the rear end also has the rest of the records. So all the remaining data, it's not just indexed values, like, for example, posting groups or post codes, zip codes, whatsoever. If you're speaking about the customer tables, for example, the index is built up of customer numbers, but at the end of this index, we also find the rest of the records, the name, the address, the posting groups, and so on. So that's how the clustered index actually defines how the data is physically stored. This means we have one clustered index because we can arrange the data just once in a certain way, and we can have, let's say, basically infinite non-clustered indexes. I think the technical limit for SQL Server is 999. In NAV, if you fiddle with NAV keys and indexes, I think we're still limited down to 40 keys, which is still too much if you have that many. One thing I also want to mention right now, these indexes can be used in actually two different ways, which I also demonstrate a little bit. The quick way is to seek an index. Seek means to run through an index top-down. Like a query, I want to find out all records of number 7, posting group number 7. Then SQL Server can use these routing points to quickly seek through this index, finally retrieving the record or the records belonging to this filter criteria. If I would have a different query, something like this, so a wildcard 7 wildcard, that would be something like, give me all phone numbers which contain a 7. Yeah, screwed. What should I do? Of course, I have to start from the very beginning to read this book. Yeah, that's what the wildcard in the beginning tells. Start at the beginning. Then I sooner or later will get the 7. But the wildcard and the end actually prevents the SQL Server to find an end. Where should it exit? Yeah. Maybe there's something beyond the 7. Is there 17, 27? Who knows? So in most cases, it is forced to scan to the rear end. So it's important to understand top-down, that's a seek. And going from left to right, a sequential reading of the leaf node level of an index is called a scan. And just this very, very simple example shows what the problem is with these seeks and scans, actually. In the first example, when I was properly seeking through this index, the SQL Server had to read 1, 2, 3 pages. And if it has to perform a scan, it's 1, 2, 3, 4 pages. So the I/O is higher when SQL Server is forced to scan. And just to have this back in your minds, because we will come back to this in a minute.